Okay, number 1, set up as a Pythagorean theorem problem. So, gives us that one leg is 7 and one is B, and then your hypotenuse is 14. You can start that off any way you want to with the 7 or the B first, either one, it doesn't matter. I wrote 7 squared plus B squared is equal to 14 squared. Okay, then I knew that's 49 plus B squared is equal to 196. So then to solve for B, I subtracted my 49. That got me B squared was 147. So then I needed to undo that squared, so I'm square rooting. So square root of 147, you can look at your choices and know that's not a perfect square because your choices still have a radical in them. Good news for you is when you're taking the test, if you don't know what the biggest perfect square that'll go into 147 is, you can look at the choices and try those. So you look there and see, like, will 21 go evenly into it? Because A's got 21. You can eliminate choices like that. But the biggest perfect square that did go evenly into it was 49. That was the same as 49 times 3. Square root of 49 is 7. So you were looking at that. Okay, very good on that one. On the next one there, it's just a multiplying problem, number 2. We had the cube root of 4x times the cube root of 25x. Now in the bell ringer it was addition, and you can't add them unless the stuff right underneath it's the same. But it'll multiply as long as the roots are the same, you can multiply. So this is cube root and cube root, so you're good to multiply. Your answer will be cube root. 4 times 25 is 100, and x times x is x squared. Okay, is there a perfect cube that'll go evenly into 100? No. 3 cubed is 27, 4 cubed is 64. Neither one of those go evenly into 100. 5 cubed is 125, so you passed it. So nothing will go evenly into 100. Squared is smaller than cubed, so it can't break down. So that's your final answer on that one. Number 3, it lets you use your calculator. You just had to remember how to find a cube root on your calculator. If you're looking for the cube root of 89, the reason you knew it lets you use the calculator is because look at the choices, they've all got decimals in them. To get cube root, you hit math, and then scroll it down to the one that's got a 3 in it, pick that, and hit 89, and I got approximately 4.465. You got to know how to round because they gave you some C and D were both close based on how you rounded. So make sure you remember your rounding rules. Alright, on 4. That foiling with radicals, y'all never were a fan of that, so that was probably a little harder for you. Let's look and see. It's got 9 square root of x plus square root of y times 9 square root of x minus the square root of y. Now the good thing about this is you'll remember, and Blake reminded us of the word, that those are conjugates. The 9 square root of x is the same in both of them, and the square root of y is the same in both of them. The only thing that's different is the plus and the minus sign. When it's conjugates, your radicals always end up canceling out. So that is good news that we're going to have here. But when we go on our first, okay, you got to multiply what's outside. 9 times 9 is 81. And you got to multiply the radical stuff. The square root of x times the square root of x is the square root of x squared, which is just x. Okay, when you multiply square root and square root, those square roots cancel out. And when I go to my last, I got a positive times a negative, so I'm negative. 9 times just a 1 out there is 9. And then the square root of x times y. See, we had an x in that one and a y in that one. On my inner, it's the same stuff except it's all positive. So I'm going to have a plus 9 square root of xy. And on my last, I've got a positive times a negative, so I'm minus. Square root of y times the square root of y. It's the square root of y squared, which is just y. So then you're looking there in the middle, and you got a negative 9 squared xy and a positive 9 squared xy, so those cancel out. So we just got the 81x minus y left, which was B. B. Okay, anybody good? Ready for 5? On 5, it's an easy one there. We've got the square root of 4 plus the square root of 100. As it is, like on the bell ringer, we can't add those because 4 is not the same as 100 underneath the radical, but these are both perfect squares. They're going to simplify all the way out. The square root of 4 is 2. The square root of 100 is 10. So should have been able to get to 12 on that one. Alright, number 6. We've got 6m to the 4th plus 8k squared, all to the negative 3/4. The directions say to write with radicals. Okay, first dilemma that we have is our exponent is a negative. When you have a negative power, that means you put it on bottom and make it positive. So I'm going to put all of that underneath 1 and change that negative 3/4 to a positive 3/4. Now it said write in radical, and that's exponential because I've got that big exponent. Remember that exponent outside here means power over root. So I'm going to have 1 over 6m to the 4th plus 8k squared. The power that gets is cubed. The root that gets is the 4th root. Scoop that up. Okay, so that would be it. Now, we know that math rules don't allow us to leave a radical on bottom, but this didn't ask us to simplify it, just asked us to rewrite it with radicals. So that would be, let's see, which one is that? A? Is that the power and the root in the right spot on A? Yep. Okay, number 7. We've got 243 to the 4/5 power. It says to simplify. You could just type that in your calculator, 243, and then your power button, and put that in. Power over root would be the other way to do it. The 5th root of 243 to the 4th power should end up being able to get an 81 on that. So if you need help practicing putting that in your calculator, let me know. Page 2. Alright, what was number 8? We got 6 to the 1/2. It says to write with radicals. Okay, that's a pretty easy one, because write with radicals, you're going to use power over root. So we got a 1 power and a square root. So 6 to the 1st power, take the square root. That'd be easy. And number 9, I've got the 4th root of 5 to the 16th power. Directions say simplify by first converting to rational exponents. That means take your radical form and rewrite it in exponential form. So if I did power over root, this would be 5 to the 16/4. 16 divided by 4 is the same as 4. So you're looking for 5 to the 4th, which is 625. Alright, for number 10, we had started making a chart of our powers of I. Number 10 asks for I to the 17th. So we didn't go that far on our chart, but we made enough to know if we look at the powers of I, if it was an even power, 2, 4, 6, 8, it was always going to have a 1 or a negative 1, right? Remember that? When we got to the odds, 3, 5, 7, 9, it was always going to have an I in it, either an I or a negative I. So I know it's got to be either B or C. Okay, once I figured that out, that I'm an I or a negative I, then I just looked at the pattern on my powers of I's, and I'm not making that chart for you again. You need to have it in your notes. But once I looked at the powers on that, I saw that they alternated from positives to negatives. Did anybody get what's I to the 17th? Is it supposed to be a positive I or a negative I? What positive is correct? Good job. So that would be C. Good job. Okay, number 11. Are we ready? Everybody staying up? Okay, on 11. I got 4 plus 3i over 5 plus 2i. Directions say to write in standard form. The dilemma is that we can't have that I on the bottom, so we need to get rid of that. So we're going to multiply it by its conjugate, which would be 5 minus 2i. Just change the sign. Whatever you do on bottom to stay equal, you got to do it on top. So we've now got FOIL on top and bottom. So on the first, that gets me 20. I'm on the top. On the outer, that gets me negative 8i. On the inner, that gets me positive 15i. On the last, that gets me negative 6i squared. And remember, I squared is the same as negative 1. So that's negative 6 times negative 1 turns that to a positive 6. Combine that with that 20 and you got 26. On your i's, you got negative 8i and 15i, which is positive 7i. So that would be my numerator. Now I got to FOIL the denominator. So I got 5 times 5. 5 times negative 10, 2i. 2i times 5. 2i times negative 2i is negative 4i squared. Okay, so again, I squared is the same as negative 1. So that negative 4 times negative 1 is positive 4. 25 plus 4 is 29. Negative 10i and 10i cancels out. So here was my numerator, 26 plus 7i. Here was my denominator, so put that over 29. Okay, then remember I told you they're going to write the choices different. I look at the choices and I don't see one like that. So what they've done is put both of those individually over 29. I think that was a choice, wasn't it? B, yes ma'am. Everybody all right? Hanging in there? Ready for number 12? Number 12? All right, 12, I've got the cube root of x to the 18th. Simplify by first converting to rational exponents. So power over root, that's an 18 power and a cube root, so it would be x to the 18 over 3. 18 divided by 3 is 6. So that would be all you could do on that. That would be 8. Alrighty, 13 is a pretty easy one, but a lot of people questioned on it. I had the square root of 147 over 5 minus 2 square roots of 3 over 5 plus the square root of 3 over 20, square root of 25. Now first off, that square root of 25 is the same as 5, right? So this is going to now be the square root of 147 over 5 minus 2 square roots of 3 over 5 plus the square root of 3 over 5. Okay, so the only dilemma is that square root of 147. It's not a square root of 3. But we saw 147 earlier, somewhere in this test. It's the same as 49 times 3, right? So this piece becomes 7 square roots of 3 over 5. 7 of these minus 2 of those is 5. 5 plus 1 of those is 6. So you end up with 6 square roots of 3 over 5. Alright, we okay? Ready for 14? 14, I've got square root of 19 over x to the 4th Okay, what we had to remember here, so when the whole fraction is under the square root, you write it both under the square root. Square root of x to the fourth. Okay, remember, if it's divisible, you can do that. Power over root would be 4 over 2, which is just 2, right? So you have the square root of 19 over x squared. You can't simplify that anymore because 19 doesn't have a perfect square in it. Alright, 15. Got some simplifying to do on it. I've got 54 minus 60 square root of 200 over 12. Alright, first thing that I did was broke down that square root of 200 because that's the same as the square root of 100 times 2, and the square root of 100 is 10. So if I bring a 10 out to that 60 that's already out there, I got to multiply that, so I'm going to have 54 minus 600 square roots of 2 all over 12. Okay, don't have any choices that look like that, so I know it's going to reduce. So I was looking for the biggest thing that I can divide them all by, and it was 6. 6 will go evenly into all of those. So 54 divided by 6 is 9. 600 divided by 6 is 100. 12 divided by 6 was 2. So that was my final answer. Last page when you get that one done. Six. I just looked for the biggest thing that would go evenly into all of them. And a hint to me, baby, was when I looked at the choices, most of them had a 2 on bottom, so I had to see 12 divided by what would make 2. Here, I got my work back up there, Bailey, if that helps you. What were you confused about?
I was, well, because I kind of got behind on it. I tried to finish it myself, but I couldn't get it.
She got A right, she just got a 4 in place of a 6.
Alright, we are looking at, I turned my page different, 16. 16, I got 7 cube roots. Oh, I forgot a plus sign. Hold on there. 7 plus the cube root of 3 times 7 minus the cube root of 3. Now, we'll look at this and we'll say those are conjugates, and you're right, they are conjugates. But on this case, this is one where the radicals are not going to cancel each other out because they're cube roots. A cube root times a cube root doesn't cancel itself out because that's only 2 of them. It takes 3 of them. It would mean a cube root times a cube root times a cube root cancel out. So you're still going to FOIL it, but everything's not going to cancel out on this one. On my first, I got 49. On my outer, I got negative 7 cube root of 3. On my inner, I've got positive 7 cube root of 3. So that part will cancel, but it's this last part here that's not. On my last, I got negative cube root. 3 times 3 is 9. Okay, so there, positive 7 and negative 7, those cancel out. So I got 49 minus the cube root of 9. Cube roots, if I do 1 cube, that's 1. 2 cube, that's 8. 3 cube, that's 27, so that's too much. 8 won't go evenly into 9, so I can't break that down any. Alright, 17 is a simple one, but it's wording, and the top of the question is a little bit weird. I think there was one like that on that Chapter 8 assignment that was similar to that also. It was a little bit different. It says the graphing calculator screen shows the graph of the functions f of x equals the square root of x plus 5 minus 2 square roots, or minus the square root of 2x plus 3. The x-intercept is given at the bottom of the screen. Use the screen to solve the equation square root of x plus 5 equals the square root of 2x plus 3. So you're looking for where they're going to be equal, which would be where they cross the x-axis. So all you're looking for is that x-intercept. So on the bottom of the screen, what does it tell you the x-intercept is? 2. That's it. Now the trick is, are you going to put B or are you going to put C? Does it ask for the ordered pair or does it ask for where they're going to be equal at? Just where they're going to be equal, so it's the x-intercept, so it's just C. Don't include that 0 in it. Alright, on 18 you got an easy one because it's got a negative underneath the radical. So you know when there's a negative underneath the radical, it's got square root of negative 108. When there's a negative and it's an even root, I need to say that. If it's an even root and you got a negative underneath, it's going to have an I in it. Look at your choices. None of them have an I. They took the easy way out with the not real. So number 18 would just be A, not real. You don't even got to worry about figuring out the I part of it. Alright, number 19. We got the negative cube root of 7x over y, which means the same as the negative cube root of 7x over the cube root of y. Alright, so we can't leave a radical on bottom. Y is not a perfect cube. What is the biggest perfect cube that I can get with y's? Or the smallest, I said that wrong. What's the smallest perfect cube I can get with y's? Y cubed, right? I need it to be a cube, and that's what Kelsey's fixing to answer my next question. What can I multiply y by to make it a y cubed? Y squared. So I'm going to multiply the top and the bottom by the cube root of y squared. So that's going to give me negative. Now on the top, I've got the cube root of 7x, because that was on the left side, and then a y squared. On the bottom, I got the cube root. Y and y squared makes y cubed. So now our bottom, the cube root and the cube cancel out. So I've just got a y on the bottom. On the top, is any of that cubes that I can bring out? Nope. So it just stays 7xy squared. Which looks like C. Alright, we ready? We good? The last one, it's got the 5th root of x to the 8th over the 7th root of x to the 8th. Directions say simplify by first converting to rational exponents. So that means a fraction, so your power over root. So on the top, this would be x to the 8/5 power over root. On the bottom, this would be x to the 8/7 power over root. Now, what do you do with exponents when it's a division problem? Subtract them. Very good. So you could, in your calculator, just type in 8/5 minus 8/7. When I did this, I was doing it without a calculator, so I got a common denominator on those of 35. That made that be 56 over 35 if I multiply them both by 7. And it made this one be 40 over 35 if I multiply them both by 5. So then 56 minus 40, that got me 16. So I had x to the 16/35. Okay, I looked at my choices and they put them all back in radical form. So I've got power, x to the 16th power over root, the 35th root, which was D. And you could have gotten the 16/35 just by using your calculator, doing 8/5 minus 8/7. But then you had to go back to radical form. Alright, any of those that you need me to go back to that I might have went too fast on, or you just didn't understand, or you needed help on? I didn't write anything down on that one, that's why. It was A, because you'll just do that one in your calculator. It was A right there. Any other ones? Okay, you'll be able to use your study guide, you'll be able to use your notes. Okay, it's 7 minus 3 is 4. I may write it down. It's supposed to be 2 screws. So that would be right. It's 7 minus 2 and 5 plus 1. Do you want this just in case or not?
I mean, if it's extra, it is.
Okay.